Project 2, DoppelGanger, find your celebrity lookalike. The task is given an test image. We would like to find a celebrity that looks like the test image. We used the code skeleton provided by the course, and we will explain the code implementation by myself, and for for data exploration and model and library, we will skip and without explaining. So the first to do is to enroll each celebrity image. So there, for each image, we we will carry out two processes. The first step is to detect whether there is a face in the image. We will use the face detector imported previously. The second step is that if there is exactly one image detected, then we will compute the face descriptor using this function imported previously. This for loop, since there are 1,165 celebrities, and each celebrity was represented as a subfolder, we will iterate through each subfolder. Equivalently, we iterate through each celebrity. And for each celebrity, there are 5 images. Then for each of these 5 images, we will use the face detector to detect whether there exists exactly one face. If no face was detected, then we will not use this image. If there are more than one face detected, we also will not use this image. So if there are exactly one face detected, then we will compute the landmarks and consequently use these landmarks to compute the face descriptor or the face embedding, which is a 128 dimensional vector. Then we will append this representation or this vector into a list along with the celebrity's name. So the outcome is that we have a list containing all the images, excluding some images that we cannot detect any face in it. So we have the descriptor, or you can say the face descriptor or the face embedding, which is 128 dimensional vector, and along with the celebrity name associated. So we find out that if all the images was adopted, they should be 5,825 vectors included in this list, but some of the image does not contain exactly one face and were thus were discarded in the iteration. So in the end, we have 5,671 images with their corresponding face descriptor, the vector, and the celebrity name. For testing, for each test image, we'll compute using the same technique. We compute the face detector, and if there is only exactly one face detected, then we will use the detected face and compute its descriptor. It's basically identical code in in building up this descriptor and testing. I should have written a function for it, but maybe next time. And the method I use is brute force, meaning that I iterate through all the 5,671 vectors and find whether which vector is closest to the test descriptor. So by closest, I mean the vector has the minimum Euclidean distance, which is the in NumPy we can use the norm function to to, to calculate the Euclidean distance. So if the embedding the if the distance the the distance or the metric is minimum, meaning that they they have a minimum distance in the embedded space. Equivalently, they are most looked alike in they are most look alike images. One of the drawback is that I only store the celebrity name. So in the end, I will find one of the images, one of the vector that has the minimum distance to the test vector, but I only know its celebrity name, so I can only print out the I only know the celebrity that most look like the test image, but I do not know which which image is the one that renders the minimum distance. In fact, I can write I the way to resolve it is to store the file name, and then we can map back to the minimum distance image. But it, the the task the task is simply to find out who is most look-alike. So I just randomly pick one of the image of the same celebrity. So well, I just pick the first. So the results may differ, but the 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 task sh should should suffice should suffice the requirement of the task. And that's it.